A shaking fan does not automatically need balancing.
The same symptom can come from imbalance, misalignment, looseness, bearing degradation, unstable airflow, or structural resonance.
Let's separate them with evidence, not one vibration number. First, make the observation repeatable. Keep the same measurement point and record horizontal, vertical and axial response, running speed, operating point and load. Compare with a trustworthy baseline.
A peak without speed and operating context is only a shape on a screen.
Running measurements belong behind proper guards and approved procedures.
Before inspection, stop the fan, isolate every energy source, lock and tag, release stored energy, verify isolation, and wait for the rotor to stop. Restore guards before restart.
Never reach into a moving or coasting wheel. Imbalance means rotating mass is not centered on the axis.
It often leaves a strong radial clue near once per revolution speed, with repeatable phase. Still, inspect the stopped wheel for dirt, missing material, damage and assembly condition, then verify by the specified balancing method. On coupled or shaft-driven fans, non-collinear axes can raise axial response and produce 1x or 2x speed clues.
Thermal growth and base strain can change alignment after startup.
Check the actual architecture. Coupling logic does not apply to a direct drive fan with no coupling. Loose feet, fasteners, bearing fits or cracked joints let parts move independently. Look for impacts, running speed harmonics or unstable phase, then inspect for soft foot, witness marks and joint motion. Tightening a random bolt is not a diagnosis. Repair the confirmed load path.
Bearing geometry can produce non-synchronous components and high-frequency energy.
Confirm the bearing type, temperature trend, sound, lubrication and related machine faults before replacement.
A new bearing will not survive if misalignment, poor fit, electrical damage or excessive load remains. The source may be air, not rotating mass.
Inlet swirl, obstructions, stall, pulsation or system effect can load blades and housing cyclically. Correlate vibration with airflow, pressure, damper position, and operating point. Correct the air path instead of repeatedly balancing a sound wheel. Every base, housing, and duct has natural frequencies. When excitation meets one, the structure can amplify a modest source. A controlled speed sweep may reveal a narrow peak and strong directionality. The fix may change excitation, stiffness, mass, isolation or mounting, not the fan itself. Compare all 6 suspects using direction, frequency orders, phase or orbit, speed and load response, and stopped inspection.
No single cell closes the case.
Require independent clues that agree with the fan's drive, bearings, support, and air system.
Controlled balance and fan tests create repeatable evidence.
Change one confirmed cause, then repeat the same point, direction, speed, and operating condition.
A lower value under a different condition is not proof. Keep before and after data with the repair record. The 6 causes are imbalance, misalignment, looseness, bearing degradation, aerodynamic instability, and structural resonance. Treat spectra as clues, preserve context, inspect safely, and verify with the same test. For a project review, send fan type, speed range, operating point, mounting, 3-direction data and photos.